Alright, so here we go. We're going to solve some simultaneous linear equations by using substitution method 1. And there's a number of ways of doing this, but here's what you need to look for. Um, if I have two equations and I say y equals this and y equals that, then this equals that. And what I mean by that, and I'm just going to hop right in to do an example. Let's say I have two equations, and my first equation is y equals 2x minus 3, and my second equation is y equals negative 3x plus 7. Well, because y equals 2x minus because y equals 2x minus 3 and y equals negative 3x minus plus 7, I can say 2x minus 3 equals a negative 3x plus 7. And so step 1, set the two equations equal to each other and eliminate the common variable. My common variable was y equals and y equals. So because y equals this and y equals that, I can therefore say that this equals that. And you'll notice I had two variables, x and y, but now I only have one variable, and that variable is x. Bring baby to mama, and if you're unfamiliar with that terminology, all I mean is you take a look at the variables. I have a positive 2x and a negative 3x. Negative 3x is smaller, so I'm going to add 3x to both sides, and I get 5x minus 3 equals, that goes away, positive 7. Move the constants, well, I should say constants, I should say move the constant. I'm going to move my constant over to the other side. I'm going to add what am I doing? I'm going to add 3 to both sides. I get 5x equals 7 plus 3 is 10. I'm going to solve by dividing by 5. And I get x equals 2. Well, the very last thing you have to do, and I ran out of space, was to sub back in for other variable. And what I mean by that is I'm going to take my answer, x equals 2, and I'm going to go back up to the top. And I'm going to say, all right, I have y equals 2x minus 3, but I just found out that x equals 2. So what's 2 times 2 is 4. 4 minus 3, and so I get y equals 1. So when x equals 2, y equals 1. Now, I guess I don't really need that thing there. Now, what you should do, and I always say people should do this, but nobody ever does, is you should then check it out. I'm going to take my other equation. I'm going to say y equals negative 3x plus 7. I'm going to plug in 2 for x. I get y equals a negative 6 plus 7, and sure enough, I get 1. And so once again, my solution works. And so this is true for both. It works for both equations, which means that this 2, 1 is my solution for those two simultaneous linear equations. These two equations are happening at the same time, and that is their common point. Now, I'm going to do two more. And here we go. Let's take a look at this one. Let's give you a little bit darker play. So if I had y equals negative 2/3 x plus minus 4, and y equals 1/6 x minus 9. So the first thing I'm going to do is I'm going to get rid of my y's. Now, I could bring baby to mama first, but here, because I have fractions, I don't really like well, that's not true. I love working with fractions. But because most people don't like working with fractions, I'm going to take a look at the common denominator, or the denominators, and it's 6. If you hear somebody crying in the background, it's not anybody in my family. It's actually my wife is watching a terrible reality TV show. This is really over 1, and this is really over 1. So since my denominators are 3, 1, 6, and 1, I'm going to multiply the entire group by 6, because my lowest common denominator is 6. So when I do that, I get a negative 12x over 3 minus 24 over 1 equals 6 over 6x minus 54 over 1, right? The reason why I do that is because 3 goes into 12 4 times, so 3 goes into negative 12, negative 4, and so therefore I get a negative 4x minus 24, 6 goes into 6 once, minus 54. So now I don't have any fractions. I'm going to add my 4x to both sides, and I get a negative 24 equals 5x minus 54. I have to add 54 to both sides. And you have to be really careful with your equal signs. Make sure you know where you're going. That becomes a 30 equals 5x divided by 5, x equals 6. I now know that x equals 6. And so I'm going to go back. I'm going to say, well, this one looks fairly easy to work with. So I'm going to say y equals 1/6 x minus 9. Y equals 1/6 times 6 minus 9. Well, 1/6 of 6 is 1, so I get y equals 1 minus 9. And y equals a negative 8. So my answer is going to be 6, negative 8. I should check it, so real quick, I'm going to do this up here because I'm running out of room. This becomes a 6. 3 goes into 6 twice. I get a negative 2 times 2, which is a negative 4, and a negative 4 and a negative 4. That's multiplication. Negative 4 and a negative 4 gives me a negative 8. So that works. Go back over this example again if you need to, because the fractions are tough. Last part. Now you might say, well, couldn't I just graph these and wouldn't that make life so much easier? The answer is yes, but let's say I had two gyms, alright? And I had gym A, and I had gym B. And the cost of A was $25 a month. But you had to put $100 down. And the cost of gym B is $40 a month, but it costs nothing to sign up. And so I'm kind of curious to see, when will these two gyms cost the same amount? So I'm going to say 40M equals 25M plus 100. I'll subtract my 25M from both sides, and I get, oops, that's not true. I'll get 15M equals 100. M stands for month. I get M equals, and now 15 goes into 100, let's see, 6, that's going to be 90, and so it's going to be 6 2/3. So they'll cost the same at 6 2/3 months, which actually is not a very good answer, but it does tell us something. We know initially this is more money, and this initially is less money. But at 6 months, this should still be cheaper, and this should still be more. So 6 times 40 is 240, and 6 times 25 is 150. 150 plus 100 is 250. So at 6 months, this one, Gym B, is cheaper. But after 6 months, at 7 months, all of a sudden, Gym A will become cheaper to join. And that's kind of useful because if you move into a neighborhood and you want to join a gym, but you're not really planning on sticking around, you will end up wanting to join Gym B. I mean, assuming that they're both equally as nice or equally as junky. But if you're going to be making a long-term commitment, it's worth the investment to go to Gym A and pay the extra money up front, because after a while it'll become cheaper. If you want to find out how much each gym would cost at 10 months, you just plug 10 in for M. It'll be 25 times 10 is 250 plus 100 is 350. 40 times 10 would be 400. So at 10 months, you're saving $50. All right, I hope that helps.